Good morning. Welcome to the Creating Optimized Builds of the ArcGIS API for JavaScript. My name's Lloyd Heberly. I'm a product engineer on the JavaScript team. And with me today is Renee.
Renee Rubalcaba, developer in JavaScript API team.
And so today we're going to talk about the Web Optimizer, and then Renee's going to talk to us some stuff about NPM and Webpack, and then we'll take some questions at the end. So with a show of hands, how many of you are already using or have used the Web Optimizer? Okay. And how many of you are sort of rolling your own or doing some other kind of tooling where it builds your JavaScript files? Okay, so you're in the right spot. Hopefully you'll come out of here with knowing a lot more than you did whenever you first sat down. So in this first section here, we'll talk about the Web Optimizer. I don't have a whole lot of slides. I was just going to take you through the documentation and some examples. The other thing I want to note is that we can't see the screens. So if for whatever reason you're not seeing something on the screen, please let us know so we're not just up here talking and you're not seeing this stuff. So just a little bit of history about why the Web Optimizer came about. In the grand scheme of things, and as fast as things change on the web, a long time ago, the CDN versions were the only versions you had access to. There was no way to use something different than what we had posted out on our content delivery network for you to get the JavaScript API. There were two options for you. You had just the regular CDN, which is what we call like the standard build. And when we talk about builds, essentially what we're saying is that the JavaScript source code is run through the Dojo build system, and we create a single, what we refer to as a single built layer file. That has a set of modules in it that are all built in to that single built layer file. So when you load the CDN, you pull this file down and it has a certain set of module functionality in it. Outside of that, if you request other modules, then your browser or the AMD loader will start fetching and pulling those modules down. That's additional request that your browser's making to get that functionality before the application can execute that and load or perform that functionality. So we had the standard, and then we also had what we called the compact build. And that was our best guess at what you might need for more of like a mobile application. And we kind of removed some of the widgets and some of the heavier like Dojo widgets and modules and stuff like that to try and streamline it for you. So those were really your only two options. There were no options for you to say, hey, I have my own custom app and I want to specify these are the modules that are in my app and I want to build my own single built layer file that's specific to my app so I can streamline the load time and the modules that are used. So that's just a little bit of background on why the Web Optimizer came about and why you would maybe want to use it. In the 3x documentation, under the references, you'll see there's a using the Web Optimizer help topic. And in order to use the Web Optimizer, you'll need either an ArcGIS Online for Organizations account login or an ArcGIS for Developers login. The standard like guest account or free open account or whatever won't work, because basically we authenticate you to the platform and then you log in and it stores your builds in the cloud. So we have to have a way to authenticate to know if you're a valid user or not, so you can store your build in the cloud. It doesn't cost you any credits to do these builds, but you do have to have the account to be able to log in. So this document goes through and talks about, things you need to know about generating a custom build and how to set that up, and if you want to publish or download that. There's an option where you can, after you've built your custom build, you can publish it to the CDN and take advantage of our the HTTP2, the new protocol that is like a multi-threaded, gives your browser the ability to fetch multiple files at the same time. So yeah, this document will lay out all the different features and let you know what things look like in case you're having issues or can't log in. And this also goes through and tells you about the different options that you can use to create a custom build. And I'll show those to you here in a minute in the Web Optimizer. So I'm going to link to a chart here in a second. So after you log into the Web Optimizer, you can just say create a new build, and you would give it a name. And you can either have it auto-detect, or you can pick a specific version. The auto-detect really only works for the uploading a zipped app or entering a URL, because basically what we do is we look in the code and figure out if you're referencing that specific version, and then we set the version that you're going to build to the version that's in your code. Otherwise, you can just pick the specific version. For simple apps, where maybe all the code's all in the same single file, this uploading the zip works pretty well. And then you have to tell it if you have a module that has your starting point, or if it's just the main index.html file that it would look for. But you upload that zip file, it gets unzipped on the server, it introspects the code, and then tries and figures out what modules you end up with. And then the next screen after that, you would get a list of the modules that it figured out that you have. If you have a public-facing application where it's accessible to the internet, the Web Optimizer can crawl your app. So basically, it'll fetch your main application and pull that down, and then do the same thing again. So it'll look through your code and figure out what modules you're using. Since you all are, assuming developers, one of the easy ways that if you don't mind using some additional code, that's a quick and dirty way of getting your build, is uploading this module list. Now, naturally, you wouldn't want to type in or manually create all this with all the modules that are in your code, but I'll show you a couple tools that we have out there that can create this text file for you. That is the one, this is the most, reliable way of getting everything that you need in your app instead of having to go through and check them. And then if you wanted to see what originally was in like the compact or the standard build, you can pick one from this drop down, and then when you click continue, it'll show you which modules are selected. And you can also go in and say, I want the, maybe you're doing editing and you're like, I want the snapping manager to be in my, my build. And so you can filter this by a specific package, or you can type in there and you can see which ones are in there. You can check and uncheck them. And this is what's going to end up in your build. And then there's some stuff in here with the advanced optimizations. If you're using multiple locales, there's that information. And I wouldn't pay attention to too much of this stuff over here. This can get you in trouble. But if you want to play around with that stuff, you can with the other multiple optimizations. So once you have all these, you would just click build, and it'll kick off the build. And then once it's finished, it'll send you an email and say, hey, your build's ready. And then you could go and download that. And for other builds that have already created, once your build is finished, you can view the build output, you can view the layer dependencies. This is just like a text file of saying what modules were created in your build and if there were any errors or anything. One of the other things is that you can publish it to the cloud like I was mentioning. So what this will do is it'll take your build that you've done and push that up to the cloud, and then you'll get a CDN URL that you can then use in your app, and it will take advantage of our our CDN stack and the HTTP2 and all of that. So you just sort of get all that functionality. So I have a simple app here that this is the original one. So if we load that, you can, if we have the JavaScript here selected in the network tab, you'll see the number of requests that were for JavaScript files. So you see all the different modules that are in there. Versus if we access this other one that is the optimized one that was using an optimized build, you'll see that there were like 11 of 57 requests. So any of these extra ones that you would see in here, you're like, oh, you could go back in and say, oh, I need the Dojo selector Acme module. You could put that one in there, and the Dojo X GFX shape. And any extra modules that you see in that request pipeline, you can just go back in, add those in, and redo your build, and then those will then show up in your single built layer file, and then you go through and you keep removing those modules, and they all end up in that single one. So the whole point of all of this is for these potential performance gains of what type of features you're using in the SDK, and then the number of CDN requests that were made, and then minimizing those CDN requests and having all of this streamlined into your single built layer file or your custom build for your app. So that's kind of the whole purpose of doing this. This is the optimizing the library for your specific application that you have built. One of the other things that I wanted to mention is I have a repo out here called Web Optimizer JS under my account on GitHub. And over the years, we've just kind of kept this list together, and I'll probably update it after this session with some of the new stuff that Renee's going to show. But there's a grunt task that I wrote, and Renee wrote an NPM task that will essentially, you set this thing up, and then you put your code inside this source directory, and you run this script command. This requires Node to be installed naturally, and if you use grunt, it requires grunt to be installed. But it'll go through and it'll basically read all the files in your project folder, and then use a regular expression to find all the paths, and it'll spit out that text file that you need for doing those, the uploading the module list. So it can be really helpful, and if you're a developer and the kind of thing is, you're good with, I would recommend doing that. It's the best way of getting the most straightforward build, is just having all those in the text file. Some other considerations that are outside of doing a custom build is if you're going to do this and you're going to download the build, or you're going to do the stuff that Renee's going to show, if you have your own web tier, use a web server that supports HTTP2. That's going to give the modern browsers the best chance of getting that content to your users quickly. There's other things that you can do outside of the app in the data preparation phase. If this is, say, for a mobile application or a front-facing application, there's things that you can do to your data. Like if you're using very complex polygons, you can generalize that using the ArcGIS desktop tools to minimize the number of vertices that are in that polygon, because the server will generalize that for you as long as you're not doing editing, but that's more work that the server has to do, and then that's more time that gets added into that queue that it takes to get the data to the client, which all of those little things added up is the overall total potential performance, or if it's bad, the negativity part of it, that is the lag that it takes the app the time to load to get to your user. One of the other things is attribute indexes. If your app is doing queries, make sure there's indexes built on those fields that they do over and over and over. That will increase the perceived performance. Limiting the number of fields that you return to the client or in the data, that just increases the JSON payload that goes back to the client. Enabling gzip compression on your web tier server, that will help bundle up, because text compresses very well, and that's mostly what JavaScript is. There's things that you can do to your image assets. There's tools with Node and other libraries that you can use that you can optimize your images to compress or optimize those images. And then, as some of you already know that you said you've been doing, is using tooling to minify and take out the white space and compress your JavaScript files. So in summary, we went over the build options that you have, where the web optimizer came from, some information about the CDN and how you can publish that, and some of the application benefits that you have. This is just some of those resources that I showed, the grunt module list, and then I also have a sample app out there that uses that grunt module, and then Renee's NPM module 1. And we'll make these slides will be available too, or if you come up afterwards, I can give you a business card if you want. So with that, I'm going to turn it over to Renee, and he's going to talk about some of the new cool stuff that he's been working on.
Awesome, thanks, Lloyd. All right, so first of all, how many people have been using the locally installed version of the JavaScript API? How many of you have been Bower installing it, right? That's the way we've been trying to do it. Bower's great. I'm a big fan of Bower. I'm a little sad it's kind of getting deprecated and stuff because it's very flexible. I can tell it to install wherever I want. I don't need to rely on node modules and stuff, but for the 4X version of the API, we are now recommending that you just npm install it. It's not much difference if you're still doing Dojo builds. You just kind of repath where the packages are to node modules instead of the same directory as your folder for your app, which is not a big deal. You have to, some of the naming conventions are a little odd. You may have noticed, like the Dojo build tools have a util module, but it's called Dojo util. So you got to kind of tweak that a little bit. And there is a certain script you have to run to tell the Dojo build tools that no, you don't want util, you want Dojo util. So we have all that documented. It's on GeoNet. We're going to update the SDK for that kind of documentation for 4X. 3X is still, if you want to build with it, with Dojo and everything, it's still a Bower install. We don't have, we're not going to be doing an npm publish for that. You could still npm install it and the other dependencies manually if you want to, but it's not as clean as it would be if you just did the 4X installation. So that's kind of our recommendation at this point. So if you're not familiar with it, npm is the package manager for JavaScript. It is basically the way this worked back in the day was that if you were doing, if you had your app and you're writing your server-side code or your APIs in JavaScript, you'd install those modules via npm, but all your client-side dependencies would be in Bower. But no one cared. They just did everything via npm. So that's where we're at today at this point. So everything goes into a node modules folder. To install the JavaScript API, you just npm install ArcGIS API. You'll automatically get the 4X version of the API. And like I said before, we still for 3X recommend that you do Bower installs, but you could kind of work around it your own and install dependencies on your own for 3X. And we did that just because it's kind of tricky to npm publish two different versions of the API that are both like new. So when 3.24 and 4.7 come out, they're both new. They're not One's not older than the other technically. So it's a little tricky to publish things like that, and it's kind of confusing. So that's why we decided to go that way. So what do you get? You get the minified version of the JavaScript API. You get the source SAS files for 4x API. And we do have instructions in the repo on how you can compile the SAS files separately from the API. So if you have an app and you just want like a different theme, and you custom theme maybe to go for your organization or something, you can do that. Take the output CSS files and just put them into your own project, and you're good to go. So that's kind of a really neat way to do it. We do put the source for all of our widgets in the API. So if you're ever curious to see how we built the search widget, for example, which is a kind of a hefty thing, you can look at the source code for that search widget. It's in there, available for you to take advantage of. And we do that because we provide the view models for our widgets, which have all the business logic, and it lets you as a guide to show how you can use the view models, maybe to create your own widgets in whatever framework you want. So let's talk a little bit about custom builds. How many people have done Dojo builds? All right, okay, cool. It's not pretty, right? I'm not gonna lie to you either. Webpack builds are not pretty. The more you get into doing the Webpack builds, the more complicated they can get. There's some things you can do to kind of minimize that messiness. But at the end of the day, when you start doing the more Webpack stuff you do, and if you've done Dojo builds, you're gonna realize the more you're kind of just, you've done this before. I'll say that much. They both create optimized builds. So let's go ahead and start taking a look at some of that. I'm not sure how to exit this mode. Oh, end show, there we go. All right, so first off, we do provide samples on how to do Dojo builds on GitHub. So we have this repo right here, Esri JS API resources. A lot of you may be familiar with this, but if you go into the 3x or 4x folder, we have a folder right now for Bower. We may keep the Bower folder in there, and I'll just put another one in there called npm. They go through, we have instructions for Dojo and require.js. For 4x, I'm not gonna lie to you, require.js optimizer is not gonna cut it. It chokes in a lot of places just because we have a lot of functionality now in 4x with WebGL and the workers and everything that we do, that the require.js just, I haven't been able to get it to work correctly. It still works with 3x just fine. That seems to not be an issue at all, at least from before. But I do not recommend trying to use require.js to build your 4x APIs. It'll load them just fine. We actually, someone at the island, we helped out loading 4x with the scene view and everything with require.js, but the build is a different story. So you can still do your Dojo builds. We provide a sample build profile. I even provide a make file to do this because make is just so simple to do. So this is with a Dojo build profile. And notice that we have these packages here where we tell the Dojo build where things go. And this is where I was talking about before, where all you would need to do if you install via npm is this, for moment, for example, the location, you just say node module / moment at that point. So you just have to do that for all the different modules in here, Dojo, Digit, and so on. This layers, we're going to talk a little bit about this with the way the Webpack kind of does stuff too, but basically you have a layer file that you want certain files in. We have these parts here for Identity Manager and Map View. These are copied directly from the Dojo, from our build scripts that we use for the CDN version of the API. So we do build layer files for Map View, for Scene View, for the web map and web scene and so on. There are certain files that just we want to be fully built and not need to require too many dependencies when you load them. So you can take advantage of this, and you can actually play with some of these dependencies too if you wanted to inside of your own Dojo builds, which is pretty helpful. So you can go through all this. There's a lot. The most complicated thing about Dojo build is probably going to be the static has features. Basically, these are flags you can turn on and off so that the closure compiler can remove dead code. So basically what happens here is, for example, if I have, Dojo sniff is 0, it's false. It's going to put if 0 everywhere I had if has Dojo sniff in my code, and then compilers are smart. They know that that's unreachable code, and it'll just get rid of it. So that's what they mean by dead code removal. So let's go ahead and just look at the API real quick. So this is what you get. We have a master branch, which is 3x, and we have a for master branch, which is going to be the 4x version of the API. And that's all good and dandy, all right? I mean, there's not much else to show here, but I did want to show where the repo's at and how you can install it. We have instructions here on how to install it for you. All right, so let's get into some cool stuff here. So a couple ways you can do builds other than Dojo. You can do a Webpack build. And there's a way you can do a Webpack build today without our plugin. It's not a 100% Webpack build, but what you do is you essentially are going to ignore the Esri modules and let Webpack build your code, your application code. So you're still using the CDN, but you still get the advantages of using Webpack to build your app code, to optimize your CSS, to do any kind of templating that you might be using your HTML for between a build and a dev environment. And I'll show a sample of that here. Oh, here we go. Is this one it? No. Come over here. Here we go, this one here. So this is the app I just showed you. This is an example app that went up a couple weeks ago on the developer site that we put out on GitHub. Example app's kind of cool. These are kind of the, I don't want to say these are the recommended ways that we show to build apps, but they're actually pretty good guides to build like a production ready app out there. We have a lot of runtime ones. It's the first time we have a JavaScript example app up. So this app is probably a bit overkill for a smaller project, but I did want to show a lot of the things that you can do with Webpack to do these builds. So I just have a regular, like an application here. I'm bringing in a bunch of custom, well not a bunch, I have like 3 custom widgets in here. And then I'm doing some cool stuff for interactions with my map. You can do reverse geocoding by just tapping on or holding down on the map and kind of stuff. And you can look at all that code, how to do that. That's not really the point of what I wanted to show you. What I do want to show is in my source folder, I've got these EJS file, which essentially templated HTML files. So if I look at this, I have if statements in here that are basically going to say that if I have an option that's true during my build process, I'm going to go ahead and include this HTML in my output. If not, it's not going to include it. This is really handy when you're doing things in a dev environment and as well as a production environment. I use this, I just used it for all of my HTML files, even though I didn't need it. Like this one doesn't have any ifs, but I already had the EJS and loading my templates that way, so I just used it anyways. It wasn't a big deal. Styles, so we do provide the Sass file for this, and I am taking advantage of some calcite web stuff as well. And I just bring in my Sass files from the widgets that I also am using. That all just kind of gets included for me there. So let's take a look at, assets. So okay, have a fave icon when you're deploying your apps because it's kind of annoying, that little error that pops up, and you kind of want to brand, even your organization. You want to brand your organization. Your city, your county, whatever it is, they have a seal or they have some sort of a logo, something you can use as a fave icon. So do use them if you have them available. You want to use these regular icons too. So I have a regular icon. This is like the Maps app icon in here. It's big, I know, but I'll show you what happens with this when we do the build right now. So let's close that up. I've got a, I use Prettier just to kind of prettify some of my Sass in here. And Prettier's neat because it kind of lets you get lazy when you write your code, and it will automatically prettify your code for you. I do not agree with some of the stuff Prettier does, especially when it comes to decorators and TypeScript, but hey, I don't have to worry about it. So it's one less thing for me to have to worry about when I am writing my code. It just kind of formats your code for you, so it doesn't change anything. Unit tests. So this app actually comes with unit tests. I mean, your app is not optimized if it's going to break. So write some tests if you can, please. We do show you how to write some tests in here. We use intern in these examples to write unit tests, and this is kind of a nice guide for you to be able to handle things on your own. All right, so let's take a look at some more stuff. Let's look at this. Let's get straight down to the Webpack stuff. All right, so this is I think what people are interested in. So for my Webpack config, you need to have an entry point so that Webpack knows what you want to build. You can point this to a JavaScript file, in this case a TypeScript file. I'm also going to point it to my SAS file because I want to optimize my SAS. And don't worry about the stats stuff there. Then you have to tell it where to go. I want to deploy this to a dist folder. This public path is used for what's called Webpack dev server. So when you run the Webpack in the development environment, you could have it watch for changes and it'll run the local host for you on the port, and then it'll update the browser after you've made changes in your code. So it's really easy to work with your code, update your code, and then just refresh the browser automatically for you, which is kind of cool. File name, this is the file name that I want my code to go to. If the Webpack decides it can kind of break my code out into pieces, like maybe I'm only using certain pieces of code at certain time, maybe I'm doing some sort of routing, it'll create chunks for me. So chunk file names are essentially going to be the main JS name, but they're going to add like a 1, 2, 3, 4 at the beginning of the name in here itself. And then I'll provide a library name because I'm outputting as a library target is AMD. With this, because at the end of the day, what I'm going to do is I'm still going to use our CDN, so I'm going to use our loader to load this as an AMD file. I'm going to consume my app now as a module all of its own, which is really kind of cool. And then this resolve, you have to kind of tell Webpack where can it look for files. So I need to tell it, yes, you can look in my source folder and you look in node modules for files. If you don't do this, you'll see some weird errors about trying to import a file and can't find it, probably because you forgot to add a resolve in here for node modules or something. As well as the extensions, tell it where the extensions are. So if you are doing TypeScript, you need to add the TypeScript extension in here, as well as the TSX if you're doing custom widgets, as well as JS files and CSS and SCSS. And if you're doing something with consuming HTML files for some reason, you have to put that in here. And any other files you might want Webpack to consume for you and resolve. And then look at here, I'm doing some interesting things here for like the module portion of Webpack config. I have a method I'm passing arguments to, and the same thing for plugins I'm passing arguments to. One cool thing I will point out too, I installed the Webpack typings in VS Code, so that gives me this nice IntelliSense here to tell me what I can add to modules here, which is kind of cool. Typings come in really handy even if you don't write TypeScript in your code. So I'll point that out. It's not an optimization unless you write code faster that way. Then what I'm doing here is that if I am in a development environment, I want some cheap source maps. This is just a simple source maps for my app. And then I have a dev server argument to how to set up my dev server. So this is kind of how you can keep your Webpack config a little clean by using external modules or functions to create the pieces of your Webpack config you need. So if we go into my Webpack folder where things are, the first thing you want is this externals one. So this is how we're able to use the JavaScript API today with Webpack and the CDN by basically ignoring every reference to Esri. And I don't really need Dojo in this case. Well, I might need Dojo in this case. Ignore that one. And I have to do one thing here. This is kind of odd because in this sample, because I wanted to really show what you could do today, I use internationalization for one of the widgets. And I use this Dojo IE10N to bring that widget in. But when I build my app, I lose my folder structure because I don't have a app/widget/widget name anymore. I have an app/main.js now. So I need to tell my code, okay, you're not looking in the widgets, you're not looking in an app folder anymore. I need to replace it with this widgets folder because I'm going to copy my file at that point. So if we look at what let's come back to the widgets to see what I mean by that. I think it's this user nav one. Yeah, user nav here. So in here, in my user nav at the very top over here, was that one? Maybe not. Maybe it was, authenticate, my bad, authenticate. So right here, I'm doing authenticate and I'm saying I want to pull my localization file from my authenticate folder in an NLS folder that's called authenticate. Well, I don't have that folder structure when I'm in the main.js file, so I have to add the widgets to the beginning of that because I'm copying my localization file over. That's the one thing you have to do at this point. If you're not doing localization, you don't have to worry about this part, but just know that if you do, this is one of the things you have to do to copy some files over and then update the externals to do that for you. Okay, so let's get back down over here. like I said, this is the main piece you want to do if you're going to be doing the CDN today. I have other pieces here which are interesting as well. This is how you have a TypeScript loader. So I want it to compile my TypeScript code for me and then feed that into the Webpack build pipeline. And then I just have some things here to take my CSS. I'm using Post CSS as well as the Sass loader. And then in my plugin, because I'm using this extract text plugin to get my CSS files, I need to output that CSS somewhere. So in the plugin itself, and this thing gets a little nuts, but in here, I'm outputting it to a CSS file as my build is done, right? So like I said, this part, the plugins part, is where things can get a little crazy if you're doing Webpack stuff, because you can do a lot of stuff in here. There are plugins for just about everything that you want to do. So for example, I have this hard source Webpack plugin. What does this plugin do? This plugin is just kind of a caching tool for when you are doing your development. It caches all of your modules and the results, and it makes the recompile process faster as you're doing your development, right? And this is one of those things that is worked on, it's out there and available for to use. My HTML templates are compiled here, and I just feed those into my Webpack plugin pipeline. I have a plugin to create a progressive web app manifest. This is kind of interesting here. I am going to define background colors and theme colors. I don't have a way to really show it except on the phone, but I'll show you the app itself. And when you use it on a phone, the toolbar at the top for the URL is a colored green, because I've been able to set my colors here as my theme color, which is really cool. Icons. Now I tell it where my icon is, and this plugin is going to go ahead and create different sizes for my icon. This is the one I showed you earlier. So it created 96 by 96 and 128, all the way to 512 by 512. And these are all the different icon sizes you want if you have your app that you want to install as a home screen app. So you may have seen in the plenary when they showed the 3D app on a mobile device, they ran it from a home screen button that they installed. This is how you do that, by providing these icons that are usable on various devices. And I have the Copy Webpack plugin, which I am using to copy various files over that I need. Like I said, my NLS files and stuff. I'm prettifying my Sass files just for the fun of it, really. Bundle Analyzer is kind of interesting. You can run the Bundle Analyzer and inspect how your bundles get created. So you can try and optimize the code that you're bringing in to create some smaller bundles after you take a look at it. It's useful sometimes if you think that your builds are a little bigger than they should be. I definitely recommend, if you want to check this out, look at some of the doc, because it's a pretty extensive doc. But it creates this nice little graph chart thing that you can look at for your builds. And then if I'm doing a production environment, I'm going to go ahead and uglify my code, which is basically just a way to minify all of my JavaScript. And as well as that, if I'm in a production environment, I'm going to create the gzipped files for all of my files, so that it's just one less step for my server to have to do when it serves out my files as gzip. I don't know how much this is really useful, because most server tech is going to just automatically gzip files anyway, but I think it helps slightly to create the .gz files for everything to get gzipped down. Then I use a plugin to compress all my images that are going to go out with my app, right? This is going to optimize all of my images. And then I use this app cache plugin, because not all browsers support service workers. Things like IE only support app cache. If you go on the MDN docs, like Mozilla docs, they're going to tell you app cache is deprecated. It doesn't matter if no one else supports it except Firefox and Chrome. I mean, it's not really deprecated at that point, is it? I mean, you have to support it everywhere else. So it's a good idea to have an app cache. You don't get full benefit you would with service workers, but you can still kind of cache your static files that you know about, which is where it's useful. Then I'm doing this other plugin here. I'll show you this in a second. This is a plugin, a Workbox plugin, that is going to generate a service workers file for me that is going to do more, let's just say, going to do some more excessive caching for my application to speed up boot times for my app. And then I do some other stuff here. I don't think I need this named modules plugin anymore, but the hot module replacement plugin is something I'm using. And this just gets me the hot module replacement. I don't think I need this anymore either. I think Webpack Dev Server at some point updated that I don't need to add this plugin anymore. It's just it's an option that passed to the Dev Server now. But I think by habit I just kind of kept it in here. So this might not be needed. So when you run Webpack Dev Server, you can pass an option to it that says I want to turn on the hot module replacement. Basically what that means is that as you update a part of your code, it'll go ahead and update that part of the chunk in the browser, and the next time that you hit that chunk, it should just get updated for you. It's pretty cool. It's a nice feature. And then I guess I am updating my, this shouldn't be here. I'm updating my images again, which I should have taken out. And then I do one more image optimization here because Chrome told me to. I turn my images into WebP format. Chrome will Lighthouse audit scores for progressive web apps, which is a tool you can use to analyze your site to how progressive web app friendly you are. They will tell you, hey, you should turn all your images to WebP because it's faster. But no one else, no other browser cares, but Chrome does. So if you want to be good in the Chrome ecosystem, you can do it. Problem is this WebP Webpack plugin is the only WebP Webpack plugin I could find anywhere. And it's kind of buggy. So I don't know how useful it is at the end of the day. I'm still trying to figure out if I can get Post CSS to do the WebP stuff for me, but I haven't found a clean solution for that, or at least one that just doesn't break every second I try it. Service workers. So let's look at the service workers bit here. So what this file is going to do is I tell it, look at my dist directories. This is where my output goes. These are all the files I want my service workers to be concerned about. I want you to just cache them all. Where's my service worker file? So this is a sw.js. This is a file that I'm going to output to. And then don't worry about the client's claim, skip waiting stuff. This is just like some service worker stuff. You can run into that if you want to. But then runtime caching. What this says here is that every time I make a request to js.arcgis.com, I just want you to cache it. Cache that result. I don't care what it is. JavaScript, CSS, SVG, JPEG, whatever it is, cache it. And this is not just browser cache. There's a separate service worker cache, which is more aggressive. You can hold, I think it's like, I believe it's something like 10% of your available memory. On my machine here, I get up to 3 gigs. I can cache the stuff. Base maps, so the raster base maps, you can cache the heck out of those if you want in here to help for some startup time. And then sharing, so this is like the items and stuff like that. This one's probably a little dangerous. Honestly, I may take this one out because if I'm caching everything coming from arcgis.com sharing, if the item is updated, and you won't know the item's updated. You may have changed the URL from an item and now you're not going to get the right thing and your app's going to break. So that's probably a bad thing to put in there, but I just wanted to try it out to see if it would help me at all. So far this app hasn't broken on me, but I haven't really tried changing item stuff. So that's just a little caveat. Careful what you start caching. You can get carried away with service workers and start caching stuff pretty aggressively, and you're going to find that you're going to blow your service worker cache pretty quickly if you try to build an offline app, for example. You're gonna hit some walls, but it's fun to play with and it's a good tool to have. So what does the output look like at the end of the day? So now my output is going to be in my dist folder. I have an app folder. I've got my main.js file, and everything is just compressed to like crazy, right? So that's all compressed down. I've got my assets file, which is where all my icons are, actually, and there's my WebP version of my icon. But then if we look down here, you see I've got all these different versions of my icon as well that have all been compressed, and I have WebP versions of all of those. I've got my HTML, and I've got all my gzip files for them. Now if we look at the app cache, what the app cache has is all the files that are currently in my directory added as part of my app cache. This means that IE will cache these files. App cache only updates if you change a value on it. So you'll see a lot of app caches with numbers. In this case, I have a little hash up here. So if something changes in the app cache, then it will update. If you just change, if you go on like app main.js and edit it for some reason, the app cache doesn't know that. You need to actually change something in the app cache for it to force the browser to update. Service worker, so here's the SWJS gets created. All of these files are part of my file manifest that are locally in my app, and they'll also get part of the service worker cache. And then there is some logic in here for the workbox service worker that I'm utilizing here to cache everything I want to cache, right? So that's kind of cool. It's a neat way to do it. You can write your own service workers. Nothing says you have to use this workbox plugin to create your service workers. You could write your own. I think I've written them, and I just think this makes it a little easier to do. So what does this application look like? Well, that's one other thing I want to show is because I've gotten a couple of questions. How do I deploy this now? I've built my optimized app. I want to deploy it. I use Firebase. You could use Surge or something like that. But basically, all I do with Firebase is I have this still JSON file that tells me where my directory is I'm going to publish it from. What files do I not want to publish? I obviously do not want node modules. I don't want my Firebase JSON out there, so I ignore those. And then the headers that I'm going to send with some information here for my service workers and for the app cache here, right? And then I just have, this is the name of my app I'm going to publish. And if I were to look at this here, let's come over here. Let's just do maps at Firebase app. So this is my app here, and if I log in, oops, didn't sign in right. There we go. So now I've got everything I told you, and if I hold down, I get reverse geocoding. There's a little web map browser widget in here that you can take a look at. And I just go through here, and I can just pick a web map out that I've got, and it'll put that web map there for me. And if I look at the over here, the sources, you can see that I'm just loading my app code here, and that's all modified. I've got my one CSS file, and then I'm loading some stuff off the CDN here. And if I come over to application, I'm currently using, I'm really using about 2 gigs of a service worker cache right now. So that means I've panned around quite a bit, downloaded some tiles and stuff. You can come down to the cache storage, check this out. So here's all the pre-caching stuff. So this is everything that it knew about ahead of time. These are all the files that are currently in my directory, but then we have the runtime cache, which is all the files it's starting to cache as I am loading stuff, right? So this is all of the current cache. And you can see some things get, yeah, I've got quite a few things here already. And then we have the app cache, but Chrome doesn't use app cache, so no big deal. But yeah, so that's how you do it. Currently today, you can take advantage of doing some highly optimized stuff for your applications. This might, like I said, this might be a bit overkill for some people. You might not need all this stuff. We're looking at maybe doing something with that CLI that I showed in the plenary, where we provide you a more simple version of this that maybe does not include service workers. It's just a very simple Webpack build to do TypeScript and your app, maybe some Sass, and that's it. We just kind of simplify it down a bit more. But if you want to get down to the nitty gritty of doing some optimized stuff, this is kind of where you're going to end up. That's why I did it, because this is, at the end of the day, this is probably where you're going to end up after you do everything that you'd want to do, especially when you start looking at Lighthouse audit scores, which make you feel bad about yourself. Yeah, that's what you're going to end up doing. So I do want to talk now, probably what people really want me to talk about is the new Webpack stuff that we're going to be doing. So the new Webpack plugin will be on GitHub by end of April with the release of 4.7. And we've put a lot of work into this just because up until now, Webpack does some very weird things in terms of dynamically loading modules. At the end of the day, Webpack's a loader. I mean, it might be a build tool, but when you build a Webpack app, it has a require function. It's got defined in there. It does loader stuff. So it is a loader. So it would just kind of break on some of our loader stuff that we do. One of the things, this is what the main thing is, the fact that if I have an array of module names and then I just iterate through the array and require those modules or require the whole array of modules, Webpack is too dumb to know what I'm trying to do. It's not able to evaluate the name of the modules that are in my array, even though that they're just right above it or something like that. We do this a lot for web maps because for web maps, we don't know what's in the web map. We may have a feature there, we may not. We may have we assume we'll have a tile there, but we may not. So we have to kind of dynamically load stuff as needed for those cases. So we updated our code. We updated the source manually. Jan found most of the places to fix them, but then I had to go into the grunt work to do it. And I broke the builds like a lot. but everything works now. Crossing my fingers. So the way it works is we actually are wrapping a plugin from IBM for a Dojo Webpack plugin. And that plugin works. It works pretty well. We've made some issues with it that we need a couple of things tweaked here and there. And they're very responsive. The guy that works on that project is great. So it has a lot of configuration to it though. So we're going to handle all that configuration for you. So a couple of things need to get copied over. We're trying to see if we don't need to do this. Currently, this copy of Dojo.js in the script file. We need this for sandboxing authentication, because we have to load OAuth stuff instead of an iframe to authenticate you, and then get your token, and then you can use it in your app. That's just a security thing. So we're trying to figure out how we can tweak that a little bit so that we can keep the sandboxing, but not need to copy these Dojo files and the stuff over for that one particular use case. Stars, so if you like stars in 3D, we have to copy over the stars because this WSV format and just the way that we reference the stars file doesn't work in Webpack, so we just copy. They mean it works, but it doesn't work as part of the bundle. So I have to copy them over and use them that way. There's this one SVG file for base map toggle. I don't know why, but it gets required differently. It gets required the way the stars do, so I have to copy that over as well. And then we have to copy some stuff for the workers. And I'll mention the caveat with workers in a moment here. Other things that we do is that if you've used loader plugins before, this GFX renderer, for example, will determine if you can use Canvas or not. If you can't use Canvas, you get some sort of a weird thing or something to go with. I think it's just SVG or something. But in our case, we know we want Canvas. So we just tell it, when you see this renderer plugin, just give me the Dojo X GFX Canvas module. I know what I want, just give it to me. The same for our Moment plugin. We use Moment plugin the Moment plugin we use because of the locales. Moment has its locales, and if you are doing something in Europe or something like that, and you need your numbers to look a certain way, and we use Moment for arcade and things like that, we need to load the right locale. But we know, in our case, we can just go straight to the plugin that we use, and it'll still work. Everything will just load as it needs to. And then what we do is create my little plugin, our wrapper plugin here. We take our options that we need, and I'll show you this loader config in a second. And then we just apply some more options to the Dojo Webpack plugin down here. And all my other plugins I need to run to copy stuff and whatnot, I'm just going to apply those plugins as well. And no sooner than we got this working, Webpack 4 came out, and everything broke. But it's not our fault. Webpack 4 broke AMD parsing. There's currently an open PR to fix it. So I haven't checked the past couple days, see if it's gone in yet. Once it does, it should be pretty quick for us to update and get everything out there. Some of these methods changed too. I don't think I use apply anymore. I think I need to use another method and so on. But then we have to, there's issues in terms of you now need to wait for the entire Webpack ecosystem to go up to Webpack 4 too, because this is not the only plugin that is broken in my testing. So essentially what this plugin does is it will use this loader config that's in here to reference the parts that I need to load via my Dojo loader. It will use a very lightweight build of the Dojo loader to load all these files in here that are AMD files, feeds them into the Webpack build pipeline, and then Webpack just does what it normally does. That's all. It's just like having its own loader for doing stuff. It's really kind of cool. And it's really kind of interesting the way they wrote it. And when they first wrote it, we were like, oh, hey, that's pretty cool. I wonder if we can just kind of take pieces of it and rewrite some of it, use it as a guide to create a real lightweight version of it. And we started looking at the source code, and no, not going to do that. They do a lot of really interesting things. There's a lot of work they put into it, and we're not going to try to rebuild the wheel in this case. And we're definitely going to give them cred on our page and everything, because they did an awful lot of work. But if I run my Webpack build, this is my dev server option. Hot is how you turn on the hot module reloading, the hot option. So what we saw here happen is that it's built the Dojo loader, so it built a Dojo.js it's going to use in the Webpack build pipeline. And at this point now, it's just going through the JavaScript API, your application code, any dependencies, and it's going to start. It does stuff very similar to what Dojo does for dead code elimination, except they call it tree shaking. And all that really means is that if I import a function from a module, it's not going to bundle the whole module. It's only going to bundle the function and anything the function uses from that module. Whereas dead code elimination says that if this is unreachable code, I'm just going to remove that code. Those are the two differences. You'll hear a few explanations for it probably, but at the end of the day, that's what the differences are. So now here's my Webpack app. And let's look at this here. You'll see all these modules that got built, and I kind of showed this in plenary. I got 70 something modules that were built, but it's not fair because that's counting the map files, I think. Yeah, it counts them. Well, no, I still have 70 some JavaScript files. Take that back. Okay, and plus my workers stuff I had to copy over. But the app itself is only using, let's come over here. Let's go to network. Refresh this. I'm only going to use about a dozen files for this app. And the largest file is my main bundle, but I have a commons file that has like loader stuff, the Webpack loader stuff and other things in there. And you notice like I'm using like the number 26 bundle and then the 45 bundle because of this dynamic loading of things happen. So yeah, it works out pretty well. And we're going to optimize this some more. We are going to work on seeing what we can do in the JavaScript API to kind of minimize the use of these bundles. So maybe you only get 3 or 4 bundles in your app kind of thing. It's kind of stuff that we're going to be experimenting on for the next couple of releases. So that's essentially what it does. The one caveat I did want to talk about with workers, if we look at sources over here, for now, because the way that Webpack is a little odd, we're trying to work to see how we can get it to work. The workers will need to be loaded via the CDN. So right now I'm loading from our 4.7 CDN for testing purposes. But that's the only piece that needs to get loaded from the CDN. The rest of the JavaScript API is built into my app and bundled in there and everything. Like I said, we're going to experiment with this, see if we can make it so that the workers don't need to come from CDN. There's going to be an option for you to set the worker loader URL, and we'll have documentation on how to do that in the API. It's just another part of Esri config. It's like Esri config.workers.loader URL equals this. So we'll show you all that stuff when this all comes out. But that's it. Like I said, it'll be open source, ready for you to use and stuff. You guys can contribute, help us out. If you know how to write Webpack plugins, please help us out. I'm trying. Thanks.
Please remember to fill out the session survey. One other thing I wanted to point out is that in the guide topics at the bottom of the page, there's a feedback link. If you want to share your thoughts about the direction that we're heading, you can always click that link, and that email is sent to all the product engineering team. So that's another way to get your feedback to us. Thank you.